to video 7.2, two sample significance tests. So for the scenario for today, there are two rival universities and they're both claiming that their graduates are more likely to gain employment within 3 months of graduation than those who graduate from the other school. A random sample of 500 recent graduates from College A revealed that 450 had employment within 3 months, and a separate random sample of 400 recent graduates from College B showed that 342 had a job within 3 months. Do the data provide convincing evidence that there is a difference in proportion of graduates who had employment within 3 months from College A and College B? All right, so we have a lot of information going on here. We know it's a proportion because it asks for a difference in proportion here. Do the data provide convincing evidence? Says this is a significance test. So this is a significance test for difference in proportions. That is something we have to remember. This is very important here. You must pool when you have a difference in proportions. For significance tests only, it's special. And so remember, to pool, you want to add your successes together and then add the total sample size together to get an overall probability for the entire problem, because we're assuming them to be one population. So we need to kind of put them together to create one overall p-hat for them. Okay, so to find our p-hat combined, we had, let's see, a sample of 500 had 450 with jobs. So we had 450 out of 500 with jobs, plus the other one was 342 out of 400. So all of our successes divided by our total sample size. So I get an overall p-hat here. This will be 792 divided by 900, which gives us 0.88. So where are we going to use the pooling? You're going to use pooling when you check normal condition. And it's going to be in your standard error, which is, remember, your standard deviation of the sample. When we write our hypotheses, we do not use the pooling because we want to go a different route there, and we'll remind you what we're supposed to do there. All right, so for our hypotheses, we need to start by defining our parameter. All right, so our parameter shows we're going to A minus B here. The true difference in proportion of college grads who had employment within 3 months. I took this straight from the problem to get my context. College A minus College B. So our reader knows how we're going to be subtracting because we were not given an order. Now, our null. We're going to assume there is no difference between the two groups. So if I write College A minus College B, I'll get 0 because they're the same. The other way you could have written this is you could have written the proportion of A equals the proportion of B. Those say the same thing. Okay. If they're the same and you subtract, you'll get a 0. So for our alternative here, probability of A, proportion of A minus the proportion of B. So when I go back and read the question, it says, do the data provide convincing evidence that there is a difference in proportions? They're not giving us a direction because they want us to do a two-sided test here. So that would be not equal to 0. So that's going to be our first AP tip for the day. If you have a significance test that asks for a difference in the parameters, that makes it a two-sided test. We're not asked, is College A more than or less than College B? We just want to know if there's a difference between A and B. That's what makes it two-sided. All right, so let's see what we've got here. Some other information that we've got p-hat for A was 450 divided by 500, which gave us 0.9. We had a p-hat for B, which was 342 out of 400, which was 0.855. We need an alpha level. They don't tell us in the problem, so we're going to use alpha 0.05. And another thing I might need is I'm just writing down things I might need. B equals 0.045. And then I had my p-hat C I calculated up here. All right, so I think I've got everything. So let's go on to our plan. We took 2 samples and we're performing a significance test for proportions, so that makes it a z-test. So we have a 2-sample z-test for, and then just name your parameter, PA minus PB. Okay, so let's check our conditions. We have random. It's 2 samples, and it says a separate random sample for each. So we have independent random samples. Of 400 and 500 students. Okay, now our 10%. We did sample without replacement. So 500 is going to be less than or equal to 1/10 of all graduates of College A. And then 400 less than or equal to 1/10 all graduates of College B. Okay. Now, and you do have to address them separately. I couldn't have, I addressed that there were, I could have written 2 independent random samples. And I chose to address that there are 2 of them by giving my sample sizes there. So our normal, that's our n times p when we are calculating significance tests for proportions. But remember, we have a p-hat pooled, so we want to use the p-hat pooled number here. So we had a sample of 500 and our p-hat pool was 0.88. So we have 500 times 0.12, which is 1 minus p-hat pool. Then we had samples of 400, and we'll do the same thing with that. All right, when I calculate these all out, I got 440, 60, 352, and 48. All of my expected counts are greater than or equal to 10. So we're okay to move on. Now, we're going to go to the do portion. So let me draw my picture so I kind of have an idea of what's going on. This is a normal curve because it's a z-score. So we're normal. We have, we'll be centered at 0 because that's our claim. And then our standard deviation, I'll give you the number now, but it comes from the standard error that we're going to calculate as part of our z-score. So that was 0.022 when you calculate it separately. So let's take a look. We would have gotten a difference of 0.045 subtracting, and it's 2-sided. So it could have been plus 0.045 or minus 0.045. So really what I'm looking for is this area and this area. Because it's a 2-sided test, you have 2 areas. So you got to remember when you get your p-value to multiply it by 2. This is why we want to draw it ahead of time to kind of frame out what we're about to do. So to find our z-score, we're going to take our statistic, the differences in our statistic, minus the claim, which is 0, and divide it by, okay, so the formula here, if you reference your formula sheet for the pooled, it looks a little bit different than how I'm going to use it. It calculates to be the exact same number, but I set this up how we were setting up the other proportions when we aren't pooling, so it just is a little more consistent for our use. And divide by the sample size, and then we'll do the same thing again, 0.88 times 0.12, divide by its sample size. I got this number by itself, that's where I got the 0.022 from. When I calculate the entire statistic, I get a z-score of 2.06, and when I look up 2.06, okay, so let's look at our p-value, I got an area of 0.0197 for this, because when I looked up 2.06, I was talking about there and greater. I know these are symmetrical, so the area on this side is going to be the same. So I just took that area and multiplied it by 2 and got a p-value of 0.0394. Now we're going to go to our conclusion. I want you to try the conclusion on your own. Conclusions are pretty important, which is why I keep having you try them on your own. Write it and then come back to compare to what I've got and see how you did. Alright, so assuming our null is true, so what I said for assuming the null is true, assuming there is no difference in proportion of grads with jobs is true. There is a 0.0394 probability of getting a p-hat A minus p-hat B of 0.05. I wrote or more extreme because we were talking about our two-sided test is not just greater than, it's also less than. Purely by chance, because 0.0394 is less than 0.05, we reject the null. We have convincing evidence there is a difference in the proportion of grads who had jobs within 3 months when we had A minus B. All right, hopefully that was helpful. Let me know if you have any questions. I'll see you in class.